even though they're not like you're just
There's like
assuming they're
11,
gonna watch the
13,
video?
there's 13 juniors.
Oh no.
Yeah.
Holy cow,
I think it's 13. It's 11 or 13. I forget exactly what the number is right now. But there are quite a few juniors. Hi, juniors in period 6. I am saying hi to you from period 1. That's pretty
And
exciting.
so is Nathan.
I'm speaking into
No.
the future. So is Nathan, and Tyler is rejecting his hello. Okay, so we are, what did I just say? We are going to finish forever card number 1. Nope, number 2, number 1 we already talked about yesterday. It's this guy. Oh, that's right. It doesn't let me select from the smartboard. Guys, is the light on the smartboard green, right-hand side, bottom corner?
Yes.
Okay. That was forever card number 1. I actually didn't label it yesterday, so let me go ahead and label it today. This is what I'm going to normally do in notes whenever there is a forever card, because they show up at random times. I'm going to go ahead and draw some sort of yellow box, and then I'm going to just write forever number 1 or forever number 18 or forever number wherever we are. Yes, I do want you to number your forevers. In some way, shape, or form, it can be like an upper right-hand corner. It can be on the part with the words. It can be on the part with the titles, as we talked about yesterday. Just make sure you set it up well. If you have any extra time today in class, if your groups finish their activity early, you can also copy down your forever cards. I think it's on the sub-plan for period 6 and period 1. You just heard the directions that are to come. But we need forever card number 2, and I said yesterday, well, this is half of forever card number 2. It's not quite the entire thing. So I'm going to actually go ahead and just show half a box, because graphs of basic functions, these are only half of them. Are you going to have to make these small?
Yes.
Yes, and if you make them small, question, can you put tons of detail on them?
No.
No, you cannot put tons of detail on them, but should I be able to tell a constant function from the identity, from a parabola, from a cubic function, from a cubic root, from a square root, from 1 over x, from 1 over x squared?
Probably.
Yes. Should I be able to see a vertical asymptote for the bottom two at x equals 0, at x equals 0? Yes. Should I see these crossing through the x-axis at all for 1 over x and 1 over x squared?
No.
No. So make sure that even though I'm having you draw them small, and just do quick little, like, this is in general how the function behaves, I want them to be as precise as possible. Does that make sense? Let's go ahead and keep going too. Oh, hey, now it does work.
Shoot.
Okay. Let me see if I can finish my box. Nope, that's not working. Is that the color I used? I don't know. That's okay. Okay. These are going to be the last 8 graphs. But technically I'm going to cheat a little bit and sneak 2 more in there. Maybe some of you can tell what those 2 will be, but let's go ahead and start on the top 4. I'm going to give you a second to get it set up. Yesterday I went a little bit fast because we were kind of running out of time, and I was really trying to finish both forever cards, but that's okay. We got close. Period 6, happy Friday. Period 1. Did I not say that already?
Sad Friday.
Oh, sad Friday. Wish we could be with you, period 6, but kind of not,
She doesn't.
because we're going to the mountains.
Doesn't wish you
There's a high of 70 and a low of 40.
She's smiling. She's lying right now.
I said kind of not, let's be honest. Okay, absolute value of x. Question, can the y values ever be negative?
No.
No! So since the y values can never be negative, then what is true about the y values on the graph? They always have to be positive, aka they always have to be above. True? So absolute value of x looks like a b. Period 6, I think we got some of these yesterday. We were a little bit ahead, remember? So put up with us, we're catching up. It's a b. It's y equals x on one side and y equals x on the other, but multiplied by a negative because it's opposite. Greatest integer function. This is the one where if you have 0.5, it says, no, it hasn't reached 1 yet. So it has to stay at 0 through all the decimals up until you actually hit the first tick mark, and then it jumps up to 1. Then 1.1, nope, it hasn't reached 2 yet, so it ends up staying at 1 all the way up until it hits the 2 tick mark, then it jumps up to 2, and it keeps going from there. It's also called the step function, if you want to put that in parentheses. But if I have negative, give me 1 second, if I have negative 0.5, if I have negative 0.5, technically it doesn't have 0 yet, so it's going to be down here at negative 1. And if I have negative 1.3, it technically hasn't reached negative 1 yet, so it's going to be down at negative 2. Okay, what was the question, Tyler? Was that you?
The hole is on
The hole is on the tick mark. So as soon as, for instance, all the 0.1, 0.2, 0.3, 0.5, as soon as it hits 1, it jumps up because now it contains 1. 1.1, 1.2, 1.3, 1.4, and of course all the ones in between, 1.4, 3, 7, 6, 8, etc. 1.9999999. They're all rounding in a sense down to 1 up until it hits 2 and says, oh hey, now it contains 2, let's go up. The weird ones are when you have, this is what you guys all did like in the homework, when you have a negative number and you have like negative 1.5, you gotta think about where it is on the number line. And just like over here, negative 1.5 hasn't reached the higher number of negative 1. So when we're rounding down, we do round down to negative 2. So question, or if I was to input negative 4.1 to the greatest integer function, what would you say comes out?
negative 4 is the height. 3.
Negative 5. Why? Negative 4.1, think about a number line, is before negative 4. So you round down. What's down from negative 4.1? Negative 5. I know it's weird. I know it's weird. And to be honest, if you see it this year, you'll see it once, but it does show up on SAT and math placement and stuff like that every now and then. So I just want to make sure you know what it is. There is another way of noting it. Grade 6, I think I showed you this yesterday. It could also be a little double brackets. Or they can just call it the greatest integer or the step function. Snazzy. Ellen, who is really just a fancy who? It's a fancy logarithm. It's a logarithm with a base of e, right? So natural log, logarithm with a base of e. If you want to write that, maybe you should. But all logarithms, all parent functions of logarithms, no transformations yet, have a vertical asymptote at 0. They hit at the point 1, 0. They're going to be at a height, for this one, ln, since he has a base of e, he's going to be at 1, at a height of 1 when x is e. If it was log base 2, it'd reach a height of 1 at 2. If it was log base 11, it would reach a height of 1 at 11. And otherwise, it swoops up. Swoop it. There you go. You're welcome. E to the x. He has this snazzy relationship with ln because one is log base e and the other one is base e to the x exponent, or the x power. Do you guys remember the word that describes these guys' relationship?
Inverse.
Inverse. Nice. They're inverses of each other. So, remember graphically how inverses look.
Across the y equals x.
The reflection across the y equals x. So, if I have e to the x, sorry, if I have ln coming down here, think the y equals x, and e to the x swoops up. They both swoop up, but in very different ways. Who's growing faster, ln or e?
E.
Oh, yeah. Which is why lots of speakers talk about exponential growth. Exponential growth. Cameron, would you mind checking my box in the office? I didn't get in there yet today. Just see if there's anything in it. So we have ln and we have e to the x. Do you guys see what's coming to finish off our cards?
Yeah.
Yeah! Trig! All right, period 6, you're all caught up. Or we're caught up to you, I guess we should say. I'm going to go ahead and full screen it. And let's get these puppies going. So, can I actually zoom in, zoom out? Wait a minute, how many trig functions are there?
A lot.
6. So why do I only have 4 graphs?
Because we're supposed to know the
I'm
end.
going to sneak in 2 more. Ready? Sine. Where does he start? In the middle? Well, first of all, what is he bounded by? How high can sine go?
2 pi. Oh.
1. How low can he go? Negative 1. His normal cycle is 2 pi. I'll say that. Cut that in half, that'll be pi. Cut that in fourths, that'll be pi over 2 and 3 pi over 2. We could go the opposite direction as well, so we have, make it somewhat symmetrical. Negative 2 pi. Negative pi, negative 3 pi over 2, negative pi over 2. Can sine keep going?
Yes.
Yep. So we could keep on going to another cycle and to another cycle. I think I was a little off on that, but that's okay. We could go ahead and split that into halves and then fourths, into halves and then fourths, Anyway, long story short, sine starts in the middle. Sine of 0 is 0. Sine of pi over 2 is 1. Sine of pi is 0. Sine of 3 pi over 2 is -1. And sine of 2 pi is 0. Perfect. Thank you. Does it work the same way backwards? Basically, except it's going to be bottom, middle, top, bottom. Now, once again, this is a non-reflected sign, a non-transformed sign, hasn't been shifted, hasn't been stretched, none of that stuff. What do we call these curves? Model waves? Good. Sinusoidal curves.
I don't know how I did
Okay. Maybe you learned something last year. Sinusoidal.
that.
That's a good thing. That's a good thing. It's encouraging my heart. All right. Cosine. What's going to change as I do my tick marks?
You're gonna start at the top.
True, but my tick marks, what's going to change?
Oh, pi? Is it?
We're gonna start in a different, or the loop is gonna be in the center.
Okay, so the loop is going to be in the center. That's true, but with my tick marks, do I need to change anything?
No.
Good. Still -1 to 1. Cut it in half, cut it in fourths. There's 2 pi, there's -2 pi. Once again, you can keep on going, but I'm just going to stop there for now. But you guys are right, the placement. Technically, it's the sine curve shifted, which is a weird way of thinking about it, but it's true. It's the sine curve shifted. In a way, you're starting where sine is at pi over 2. So at 0, cosine is 1. At pi over 2, cosine is 0. At pi, cosine is -1. At 3 pi over 2, cosine is 0. And at 2 pi, cosine is 1. And if we go backwards, same dealio. Middle, bottom, middle, top. Okay, what's the cosine one called?
Sinusoid.
Cosinusoidal?
I think we already chose it.
Sinusoidal. They're both sinusoidals because aren't they the exact same shape?
Yeah.
Should I have actually gone higher? No, I apologize. There we go.
Could you read the name of the
Yeah.
curve?
Here we go. These are called sine, like sinus, like in your sinuses. Sinusoidal curves. You don't have to write this in here forever. Don't write it in here forever. I'm just showing the spelling.
Too long.
Sinusoidal curves. Don't write that in here forever. There's its space. Tangent and cotangent. Not yet. Who am I going to sneak into the sine and cosine curves?
Probably cosecant.
Cosecant and secant. So I want you to write a second one. Y equals cosecant. Or PS. Another color might be really nice. Or call it like Y2 and the other one Y1.
Do it again.
Could call him Y1.
And do it in purple.
Could call him Y2.
They do go on the car.
Same graph. We don't need to draw another graph. Didn't I show you guys last year? The easiest way to draw cosecant and secant was to bounce off sine and cosine.
Yes.
Did Mr. Chase show that too? Who is cosecant from forever card number 1? Cosecant of x equals 1 over sine of x. So, 1 over sine is the denominator, so whenever the denominator is 0, I will have a vertical asymptote, an undefined. So, every time the sine curve crosses the axis, every time sine is 0, which is every time there's an x-intercept, cosecant will have a vertical asymptote. True? Go find all the zeros, make them all vertical asymptotes. Hey, hold on, while we're at it, secant is 1 over who?
Sine.
Wait,
Cosine.
Cosine.
Sorry, wasn't paying attention.
Which means whenever cosine is 0, secant's going to have a vertical asymptote as well. So let's go find all his zeros and just keep it going. Ta-da. And then 1 over reciprocal, so whenever sine is 1/2, cosecant will be 2. Whenever sine is 1, well 1 over 1 is 1. Whenever sine is 1/2, cosecant will be 2. What does cosecant do? Bounce off it. What does cosecant do? Even in the negative direction, bounce off. Bounce off. Once again, it should be within the vertical asymptotes. Don't be sloppy just because it's a sketch. I'm not making you label every single angle, but should be precise. You guys remember cosecant? So what am I gonna do for secant? Same thing, bounce off. I'm not gonna show the whole line, but then there will be another vertical asymptote and it will be like that. There we go. I don't know. That's not good for you. I think when I was driving. There will be another vertical asymptote. Ta-da! There was a something. I'm just going over it. Tangent, cotangent. Who is tangent? Sine,
Sine
over cosine. Oh hey, it has the same denominator as this guy, right? As secant, because secant is 1 over cosine, tangent is 1 over cosine. So tangent is going to have vertical asymptotes every, well, where were these happening? That's 2 pi, that's pi over 2. Yeah, every half pi. Or I should say every half pi and then pi away from us. We're going to go 2 pi over 2. Okay. And 3 pi over 2. And we're going to go this direction. Don't put the whole way. Negative 2 pi. Negative 3 pi over 2. Negative pi. Negative pi over 2. There we go. Whenever cosine is 0, tangent is undefined. Whenever sine is 0, tangent is 0. So, our vertical asymptotes at each of the pi over 2's. And whenever sine is 0, which you should be able to see up above in the sine curve, which happens 0, pi, 2 pi, 3 pi. Tangent will be 0. Could keep drawing it forever, I'm just going to draw parts of it. And most of you remember that tangent looks similar to, the values look different, but looks similar to a cubic function in the sense of its symmetry. But it repeats, it's a periodic function, just like sine and cosine. Not going to draw all of them, but yes, it just keeps on going. That was the vertical asymptote, and that already said. Tangent is always increasing. Remember what cotangent was doing?
Decreasing.
Always decreasing, except whose cotangent's denominator?
Sine.
Sine. So whenever sine is 0, cotangent will be undefined, and whenever cosine is 0, cotangent will be 0. So I need to go ahead and switch all of these. I can still do the same tick marks, but I'm going to instead put the vertical asymptotes on each multiple of pi. Including 0. Because cotangent cannot have the same vertical asymptotes in zeros as tangent because they are very different fractions. Right? So everything flips. What was a vertical asymptote for tangent is now a 0. What was 0 for tangent is now for cotangent. Vertical asymptote. You can think cotangent is displaced from the origin. Tangent is around the origin. And he's always decreasing. There we go. As soon as you guys get that one down, you now have all 16, technically plus 2, 18 graphs. I snuck in the 2. That are to be your forever card number 2. And what is the name of this card?
Basic graphs.
Yep, basic graphs are graphs of basic functions. I'm going to go back really quickly, and just write forever card number 2. You don't have to necessarily write forever number 2. You could just write number 2. I just want it numbered somewhere. Does that make sense? On the card itself, because I want you to be able to flip to card 13 and not have to make like a table of contents or something like that. All right, cool kids. With that, we need to transition. Had them. Oh, here they are. To the activity. Okay, every group gets a green sheet. If you want, you can start looking at the green sheet. You are not allowed to write on the green sheet. Using the same green sheets period 6 will be using. Period 6. If you look over next to the computer where I run my smartboard from, the one behind the whiteboard, I'll pass over to Heather for the other groups. Yeah. Period 6, sorry. If you look over by my computer, right up from my mouse, or let's just say beside the mouse, that'll be easier. I will have these green handouts. Every single group needs to come on up, send one representative, and get a green handout. But at the same time, every group only gets one green handout, but every person in the group needs the other paper, the white paper next to the green handout, up on my computer, called a graph match. Let me go ahead and pass those out to period 1, period 6. Whoever your representative is, also get one white paper for every person in your group. So only one green sheet per group, but one white paper for every person in your group. There's 1 and 2 and 3. I think that's 4. Let's make sure. 1 and 2 and 3 and 4.
Okay, Misty, is there any way to take an L on this?
No. Pass that to Crystal. And then one, the whole thing actually.
Oh. This is
I don't want to watch this. Okay. Okay, I want us to read the directions really quickly all together. Period 6, you should be close to having everybody with a white sheet and each group with a green sheet. Period 6, if you need to rearrange because the seniors are gone, go into the junior groups that we talked about yesterday, the junior senior groups. Okay. Heading should be self-explanatory, name, period, group number. Go ahead and put your normal seating group if you remember it. We'll talk about it on Monday if you don't remember it. What do you guys see on the white sheet that everyone is supposed to fill out? Okay, true. You see equations. There we go, that's what I was going for. You see equations, right? Equations of functions. All of them in function form. Y equals a function of x. But many, many, many different types of functions. So you guys really quickly give me a letter and give me a general type based on the 16 basic graphs that we've talked about of what type of function it is, even though it's transformed.
Figure 9.
Wait, give me a letter. Okay, J. And then what kind of function is it? It's an absolute value function, true, but you also have to consider it's a quadratic. So it's a quadratic in an absolute value function. Ooh, it fits in 2 categories. How about letter K? What would you guys say that is?
Piecewise?
Piecewise, true, but what about the pieces?
It's probably oh, there's a parabola.
Okay, there's a parabola for part of it, or part of a parabola, and then a constant. So there's a constant function, a parabola, and another constant function. Interesting. How about letter H?
H. Absolute value of...
Absolute value and logarithmic. I have to think about both. The big picture is a logarithmic, but I do have absolute value on the inside. Now, kiddos, have these functions been transformed from the parent function? Yes.
Yeah.
What do you see on the green sheet? What are all those screens from? A graphing calculator. But the dilemma is, what don't you see? The y equals. So what is your job? What function made that graph? Is this an easy task? Somewhat. Can it get hard? On some of them. Let's read the directions really quickly. Match the equation on this page, the white page, with the corresponding graph on the other sheet. Do not use your calculators unless absolutely necessary. I mean it, and just listen as to how much I mean it. Use any idea you've learned about intercepts, symmetry, asymptotes, domain, range, and extrema, mins and maxes. Basically, you use all of your knowledge about the basic graphs and transformations. Not all graphs are drawn to scale, aka not all windows are zoom standard. Does that make sense? Okay. Write the number of the graph next to the letter of the corresponding equation you think it is, and state C or NC, for calc or no calc. as to how you did the problem. You will receive 2 points towards the total, which is a max of, how many letters are there, 25? 50 points total?
Yeah.
I think it's A through,
Yeah, it's 25
Yeah.
because there's one.
perfect. So there are 50 points total possible. You will receive 2 points for each graph identified correctly without the calculator, and only 1 point for each identified correctly with the calculator. Absolutely no discussion is permitted, fail. Cross off the last one. Absolutely no discussion is permitted. Cross off the no discussion is permitted part, because you guys, I do want you to discuss, I do want you to collaborate. However, no textbook and no other material is permitted. The only thing you can use are your forever cards, aka your notes that show the forever card information that will soon be in your forever cards, hopefully by Monday. So you are allowed to use basically the basic graphs I gave you. Dun, 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 and your brains and each other. Now, pause. Why on earth, Ben, would you ever use your calculator if you're only going to get half points on it?
Because you're too dumb to figure it out.
What if you have 3 you don't know and you'd rather
Get point.
get
those.
1 point and then 2 and 2 than no points out of 6? Does that make sense?
Yeah.
That's gonna be
Ready, set, go.
Okay.
Hey,
So we have a few.
Period 6. I am not watching as to whether or not you use the calculator, but the sub will. Thank you, sub.
She says, the number.
Period 6, I'm still recording, but hopefully you're working. You should not just be staring at the screen blinking.
Just things, none of these
Make sure the calculator works.
an absolute value of a per hour.
No, that was me.
Is that calculus? Misty, when it says calc, does that mean calculus or calculator?
Calculator.
Okay.
So put a C for calculator, put a NC for if you did not use your calculator next to every single problem.
So,
Please.
because of this way, we do have.
Remember when you do extra points?
Oh,
So
okay. I
negative.
think so.
Where you're at, and I'm all about it.
Oh,
I like E as
Does it work?
What figure? 21 is,
Wait, this one is gonna be negative. Just 17, or just
on the top.
oh, it would be and.
Just be the cosine, it only goes up.
Like, so it's not.
I don't know if the number. Yeah, I see
So
that.
that would be and.
There's the cube solution. So it's really 20.
Misty, do all of the numbers line up? Okay, I'm not supposed to ask.
What do you mean if the numbers don't line up? There should be an answer for every single problem on the white sheet.
No, I mean,
This is
for
really
information
big
stuff seem to line
So,
up.
number 15 goes.
The window is not necessarily a 10 by 10.
Well, like, oh, so.
It could be zoomed in,
Is
zoomed
every
out.
line not the plus or minus two?
Right, because for sine and cosine, well, if it's in radian, I guess it would be okay. It's not necessarily a 1.
Okay, alright.
Yeah, you could be zoomed in, zoomed out.
That's how we have it.
No.
And for instance,
Oh, it's a problem.
guys, on letter, no, figure 16, hold on, pause. Hold on, pause. Figure 16, you guys have to be careful of what it looks like and what's actually going on. Do you think that comes to a point or not? Figure 16. Do you think there's an asymptote? It could be an asymptote or it could come to a point. Don't necessarily assume that it comes to a point and
Make it so
stops.
hard.
It could be an asymptote. Well, you got the calculator, only shows you so much.
So,
Oh, yeah, that is right.
okay, so the absolute value of x plus.
Then actually,
So figure 8 is going to be because
But it should have
has
been
just
4.
remember how natural law is
why you
break it down.
negative
Since we
which
have
is
to take it
just
as
this by itself.
absolute value, it's gonna
Squared
bounce off and come back up.
Okay, so this one, you have radical law.
Yeah.
Figure 5 is definitely X of 4.
X plus
Oh, wait, no,
X
it-
minus 2.
Oh, X.
Okay, well, this is exponential, so this is just e of x. Number one is just g.
That's not the only thing I'm thinking. Only because the parent function looks like that's the closest thing.
Because that's how an exponential works. Yeah.
Or maybe this one.
Oh,
This
Or
is
figure
a ordered function, so it's a x to the fourth, so that's I. Number 5 is a fourth root, number 4.
Wait, isn't it more
So it's number 5.
You know what I'm
Wait, this
saying?
one is gonna be
This is
like,
not
11 is gonna be.
So what's ln of x? ln of x.
Yeah, it curves a little bit.
Yeah.
But if you have this,
Between 16
wherever
no, it can't be 16.
So wait,
x to the middle, and it just goes on.
This one's
It's not
fine.
16.
That's why it's definitely.
Figure 11
How about like 16 or two signs?
And then that was okay, it's right. It says that it's still gonna come back to this. Do we find something else that's
You still have, wait, you still have, oh wait, that's not working. There's just a
I think that's probably
Yeah.
So you know what that is?
It's
That's
just to the negative x, right?
right here. It's 1 over x.
Where is it?
So 1 to 1.
Oh, and this one would be the opposite like sign.
Oh,
Because it's bounces off.
no, after.
So with this one right here, we have a 12 1. It's something
Well, Alan is absolute Alan, so you can't have a negative Alan.
I think you get to shift it over 1
Absolute value.
to the right. Yeah. Oh wait, no, it's definitely.
Oh yeah, we do, down here. Oh, that's why it looks
Do you guys want them in page protectors so you can like expo mark around the ones you've done? Let's do that, that'd be a good idea.
Shifted down 1 left.
Oh no, that's the 4
X squared is like
probably 4.
Yeah, right here.
X squared, yeah.
If you slide the green sheet,
What is our forever target?
This one.
take 2.
Oh, I thought you were talking about
That's the only way we could do it.
Well, for this one, you need to plug in because you have a group line.
Period 6, if you look underneath the green sheets, there will be page protectors. If you come up to get your page protectors and put the green sheets in them, you can grab an expo marker
But that's
from the box right beside them, and you can actually mark off the ones that you've done. Makes it a little easier. Just make sure when you turn them back in at the end of class that you erase your marks. You can use the towels that are right next to the white sheets. If you guys want to put the green sheet in, you can be able to mark off the ones.
Oh,
If you guys want, you can put your green sheet in. Use an expo marker to mark off.
Oh yeah, I know, that's right, yeah.
One.
The calculator makes it look like it stops, but it's just kind of flat there. It does probably go up. You guys want to put the green sheet in there, and then we can use the expo to mark off the one that you
Oh, yeah, we did find.
Whoa, genius.
Oh, because there's also the absolute value higher.
You want to put the green sheet in there?
13, oh, well,
Use an expo.
Y equals X.
To mark off the one that you said.
Oh my gosh. Because we were lightly.
Wait, we were lightly drawing.
See, there you go. This is easier. Then you can preserve the integrity. Alright.
20.
Grade 6, so that makes sense. Put the green sheet inside the
Oh,
notebook.
I did it. It's,
Oh no, throw it away!
He's dead. Hold up.
I just filled it out before, on accident.
Oops.
Oh, no.
Boy, what just happened?
I mean, Sean, great basket.
What just happened? What? Did you fail?
What are you saying?
So 20.
He was trying to, and then it just.
He totally made it.
I think that's all.
Yeah,
because he's dead.
totally made it.
It's a, no,
So we did.
yeah, 20. So 20, it's.
Everybody else's markers work alright.
Good
You have
job.
one.
Remember, if you find a dead one, just toss it.
Between 0 and 1.
24.
Between 0 and 1, and then a line.
One.
So it has to be 20.
5. 12.
When it's absolute value.
Okay, no, you're not better as well.
So.
So you assign that.
Oh yeah, so it's.
Yeah, absolutely.
It's in the middle. Yeah, it's outside the next.
But it's like this, I think it's. This one.
Well, at least he's finding out all the bad ones.
Oh my
I have more ready to throw at you.
Okay, there we go. That one's boy.
Here we go.
Okay.
Negative, so it has to be.
I think.
Yeah, that was touch, right?
I don't know because
I think so, too.
Oh, so it'd be shifted to the right.
1, 2.
No, it'd be shifted
Yeah, 1.
It'd be shifted up. So.
Next one is how upside. You didn't tell me.
So.
Oh, yeah.
Someone did this to you.
Which is 3 ways. Oh, this one?
Oh yeah, this one.
So you could do. But it's, oh,
It's x squared also, so.
I know, it's x squared that's just tripping me out, because usually cosine squared plus sin squared is 1. And it's at 1. But you have a square. Yeah. But I don't think squaring the x would change it, and if there's no other value.
Do you guys remember what absolute value does to a function when it's on the outside?
Yeah, okay. Oh, you're right. You're right.
It takes the y's that were below and makes them above.
So on the
So maybe that's what it is.
So that'd be one.
And when there's an absolute value on the inside, it takes the right and makes the left look just like it.
Wait, that's absolute value?
Absolute value on the outside takes the y's below and flips them above. Absolute value on the inside takes whatever's on the right and makes the left look just like it, and the left goes away. In case that helps.
Oh, that's very good.
It should be two sides.
The right
outside.
gets copied on the left.
Is
It's on the inside.
Bottom
11.
yeah.
is on the inside. Okay, hold on.
This one should be okay.
Why haven't we found this one yet? This one's supposed to be constant, but I can't.
Oh, so I see it pours on number.
Oh, yeah.
I was thinking
This figure 4 would
it was,
because think about
Oh, yeah.
because it would go one way down, but it can't because
But it was too late for me to stop them, so.
but it's still parabola. So it technically would go parabola, it's all like here, but it has to stop here. But it's
Wait, I mean,
Where's it come
Because
from?
it's
20 is on.
I think it probably it goes here and then goes under to that one. But
V is going to. Let's just.
but for an absolute value, no matter what, even if it's on the outside or inside, it goes below. Okay, if it's on the outside, it can't go below the y equals 0.
If it's on the outside.
Okay, I did
If it's on the inside, not necessarily.
only that one
You
part.
plug in positives, but you might get out of it.
Okay, because of the stuff on the outside. Okay. So basically, this is it goes with J and number 6 goes with
This is a secret. That would be like a.
Okay. So for this one, negative x plus.
No, because if it was opposite value, this part.
Which absolute
I'm
value?
looking at
On the outside or on the inside, Sean?
Like,
Sean? The one you described, is that absolute value at all, or on the outside or on the inside?
and then put it over.
yeah. So it should be like
Do you want
this.
me to say again what absolute value does? Absolute value on the outside takes any y's below and flips them up. Absolute value on the inside takes whatever's on the right and copies it up.
No,
So then, because an x squared, what does it have?
Oh, well, okay. Oh, no, I mean, 8 is,
You have.
is X.
I'm pretty sure that was 7.
Oh, but the flip y.
It's plus or minus 2. So your vertical axis is 2 plus or minus 2, and this one
Those are
has.
ones that you should know a little better, that are more basic.
Oh, that's the.
Yeah.
And then narrow down, and then see what you have left.
It doesn't look like one of those curves.
So this is the one. Oh, okay, but yeah.
But this also has, oh no, this is a.
Would it be sine squared x equals cosine squared?
That's kind of like a reference.
It's just way on it.
What if we did it wrong?
Absolute value.
Wait, do we need to finish this?
Do you need to finish this? Okay, you guys process it.
Wait, Mister, do we
Do
need
the best you can to
oh, like,
Okay, so the L and,
Okay, pause, before you start like throwing in the towel and suicidally going to your calculator. Remember there are seniors who are gonna totally miss this activity in period 6? I did tell them I would try to have some class time available on Monday for them to work on it, not to finish it, but to work on it. Guess what that time will be for you guys, because I want the
To work on
classes
this.
you can finish.
Thank goodness.
So right now, don't go to your calculator and start graphing everything. Right now, try to at least make the answers that you've put be as definitive as possible, and then get that green sheet as erased as possible. Because period 6 needs to use them, and then when you get back on Monday, you can go marking off the ones you've already used and keep going from there.
I was supposed to erase it.
Oh, with the towel.
That would help.
And I will take the green sheets and the page protectors and the towels and the markers
should we get the
back
white sheet
right
out?
over here. Hold on to the white sheets, those are yours. Don't lose them, bring them on Monday.
You want to be able to get it?
You haven't given me your combo yet.
Oh, period 6 people, sorry, yours might already be in page protectors.
Boom, boom.
Go on. Keep singing.
See you, Mister.
See ya.
Have you ever blood?
Have a good day, guys. Happy Friday.